Hope this finds you great wherever you are, and I'd like to welcome each and every one of us to my channel of Honest Sciences and Mathematics TV channel. In today's preview, I'm going to look at an interesting concept of mechanics, and this is going to be a broader topic that is going to be, of course, spanning across the various, disciplines of physics and chemistry, and it's going to be widely borrowing from the various topics that we have learned in mathematics in order to interpret the various aspects of quantities which we are going to be learning. And in some sense, we're going to see that for us to derive some of the concepts which we are going to be describing in, mechanics is going to be requiring us to have some basic knowledge of mathematics. So therefore, it's going to be a discipline that is going to be relying heavily on other subjects which we have already discussed. And I'd like to invite our members to be checking various links which we are going to be sharing across our social media platforms and our main YouTube channel. Now, in a sense, I'm going to be sharing of basically what we're going to expect in our various discussions under the concept of mechanics. And this is going to be entailing some, basic topics which are going to be spanning from the basic to the complex aspects as we are going to be going by. Now, in a sense, under this specific topic of mechanics, we shall look at different areas. And as I said, we are going to be, in this specific discussion, of course, we are going to limit ourselves to the concept of classical or Newtonian mechanics. So therefore, we shall look at the concept of linear and angular displacement. And this is going to be followed by their various aspects which are going to be basically describing the concept of displacement, velocity, and acceleration. And this is going to be giving us a way in which we can describe these specific aspects of motion in terms of their linear and angular displacement. Now, in a sense, we're going to come up with various range of equations which basically are going to be described as kinematic equations, which I'm going to be, of course, sharing a link. Of course, I said that we have already tackled part of these specific topics, which are going to be providing for us a basis of understanding the subsequent topics. And as such, we shall look at one of the fundamental aspects of mathematics that is going to be involved in this specific aspect of mechanics. And this is going to be the concept of vectors, which we have done in some of our videos, especially on the concept of vectors and vector analysis. So this is going to be giving us in a way which we are going to be describing quantities that possess magnitude and direction. And this is one of the ways in which we are going to be representing these various aspects of a linear and angular displacement that are mentioned in terms of a graphical representation. Now, in this case, the Cartesian coordinate system is going to be providing for us a basis of trying to represent these specific quantities. And that is going to be a convenient way for us in trying to, of course, describe this specific aspect of what we refer to as classical mechanics. Now, in a sense, we shall look at different areas as well that consist of what we refer to as potential energy, of course, kinetic energy and work. And we're going to see how different, of course, states which can be used in order to describe these various states of these objects which are going to be under consideration. Now, in a sense, we're going to see that the potential energy aspect is going to be describing the energy of stationary bodies or bodies which are going to be at rest. And the concept of kinetic energy is a description of basically the energy that is going to be possessed by objects that are under motion. Now, the aspect of work is going to be involved where force is going to be applied, of course, in this specific change in terms of perhaps potential energy. And in this case, we shall explore other areas like the work energy theorem that is going to be, of course, creating some of the relationships perhaps between potential energy and kinetic energy. Then, in a sense, we shall as well look at the concept of conservative forces. And in some of my videos, I've basically explored this specific aspect of conservative forces and said that these are forces which are going to be, involved in, in moving and, forces which are going to be involved in moving an object from one part to another. And in this case, this is going to be all the work involved, the work done by a force in moving an object from one point to another. And of course, this specific work done is independent of the path which is going to be taken, or rather we can describe it as work that is done by an object work done on an object that is moving in a circular or in a closed path. Now, in a sense, we have described this specific aspect of course, conservative forces, and as I said, is going to be contained in a link of that specific video. And then, of course, we shall look at the concept of a symbol harmonic motion, whereby we're going to see that we can describe a motion of a simple system such as perhaps an object that is attached to a spring. And in this case, we are going to be doing an application of what we refer to as Hooke's law in trying to, of course, measure the kind of a force applied on this specific object, of course, on the spring by this specific object. And in case there's a motion which has been initiated, and of course, we're going to see that we can be able to describe this such a kind of a motion using the various aspects of a kinetic and potential energy which we have learned. Therefore, we shall derive a various range of equations which are going to be assisting us in trying to describe this specific motion. And it's going to be in terms of a second order differential equation whose specific solutions can be given in terms of functions of the cosine and the sine, as I have already explained in these specific videos. So in a sense, we're going to see that such a kind of a system are going to be providing for us a basis of understanding various other aspects which we are going to come across in various topics. And this include understanding interaction of elementary particles like atoms and the molecules, which I've talked about in my various videos. And in a sense, the concept of a simple harmonic motion as well, or rather a motion in one dimension that we're going to be using to describe this specific aspect of a simple harmonic motion, is going to be giving us a basis of understanding the sounds of various instruments that we're going to come across, apart from it giving us a clue on how radio, TV, and communication of course, signals are going to be working. So therefore, this is going to be also forming a basis for us in understanding the nature of light and color. Sorry for that. And of course, we're going to see that in study of vibrations in car engine, shock absorbers, and the brain waves, of course, this is going to be forming a basis of us understanding this specific aspect. So we're going to see that there's going to be a wide range of applications that we're going to be borrowing from this specific concept of mechanics. And of course, it's going to be assisting us understand various ranges of aspects, of course, stretching from the physical world to other natural phenomena, which we have just mentioned. Just a few of them, of course. These are mainly the application areas which are mentioned, but for us to understand how the natural world works, like the motion of our heavenly bodies, this is going to be coming handy for us. So at the tail end of this specific, of course, videos, we're going to explore various aspects of this specific motion and application, of course, which constitute the moment of inertia. And this, of course, is going to be, of course, being accompanied by various aspects like the parallel, of course, and perpendicular axis theorem that we're going to be exploring, perhaps in terms of various illustrations. So we shall study the concept of the radius of gyration, and then therefore we are going to be ending these various discussions with the concept of rigids of dynamic, of course, or rather the rigid body dynamics, which is going to be assisting us try to describe various aspects of torque, momentum, translational and rotational kinetic energy, and the translational potential energy. I'd like to invite our members to be checking various links of videos which we are going to share. And this specific topic of mechanics is going to be spanning across various range of videos, as I've said. And this is going to be, of course, assisting us try to understand various range of the foundation aspect for the study of statics, fluid dynamics, and of course the connection between the aspect of a theory and application, which we are going to learn. And of course, in us understanding this aspect of course, mechanics, we're going to be having a basis of us interpreting the various natural phenomena which we are going to come across. And of course, we're going to see that in applying the various engineering concepts which we're going to come across, they are going to rely heavily on this specific topic of mechanics. And of course, we're going to see that in the space and medical technology, which are going to be, of course, the other frontiers which we're going to explore, this is going to be coming handy together with the orthopedics and medical, of course, medical aspect of orthopedics, and of course, the automotive design industry is going to be relying heavily on this. So it's a wide range of applications which we're going to be coming across, to mention about a few. And this is going to be assisting us in trying to interpret the various aspects. Now, for us to understand the basics, then therefore that's going to be forming a basis for us in trying to explore the other wider world, which I've just mentioned in this case. So as I've said, kindly link with us through the various platforms which we are going to be, of course, having discussions. Engage us in the comment section, and also ring that notification bell, subscribe, and also invite more members to join our group for us to have a meaningful discussion in the various topics which I've mentioned. So lastly, I would like to wish you the best of our endeavors in your various areas in different parts of the world. And I'd like to wish you the best of luck in whatever you do. So that is it for now, guys. Bye. God bless you. Catch us in our next video.